All right, this is Mrs. Short. I'm going to review direct and inverse variation with you, basically the things you learned in Algebra 1 pertaining to this. In class, we will go over this a little bit, and basically in Algebra 2, we have to add a little bit more to it. So now I'm making sure that you know everything from what you should know in Algebra 1. So the basic thing about direct variation. In direct variation, variables are directly related. When one increases, the other increases. When one decreases, the other decreases. Your main equation is y equals kx. Hopefully you recognize that a little bit. So this is something you want to remember and know pretty much. You won't be told what the equation is. Now, just as a side note here, you do not have to write any of these notes down. Just watch and pay attention as I go through the examples. At the end of the video, there are 4 problems for you to show your work on and do and turn in class for your homework grade. So anyway, as I was saying, y equals kx. So, you should recognize this is similar to y equals mx plus b, the equation of a line, but the b part's gone. So if the b part's gone, that means we always start at 0. So if you were to graph a direct variation, you would always expect it to go right through 0, right through the origin, and it just has some slope. If it has a positive slope, maybe it looks a line like this. If it has a negative slope, maybe the line looks like that, but it goes right through the origin. When the x increases, the y increases. When the x decreases, then the y decreases. So either one. Realize that you can also take this equation and transform it a bit. If you have y equals kx, say you divided both sides by x. So you might have an equation that looks like this. Y over x equals k. This is just another format of the original equation. So you may see this as direct variation, and it's fine. All right, so we're going to do a few examples now. All right, so these 2 problems. In these 2 problems, you're just recognizing what looks like direct variation, basically. Now, a couple of them, they're a little bit harder. These little things right here, this is v equals k r to the third. This is v equals k over r to the third. And this one's r equals k v to the third. This is v equals kr. A little bit hard to read. It says the volume of a sphere varies directly. So when I do these problems, I always start writing my answer. This tells me the volume varies directly, so I write v equals, always put the k. It varies directly with the cube of the radius. So cube right here, that means we're doing the third power of something. So the cube of the radius, that means I need r to the third after my k. So r to the third. And there I go. I got my answer. K r to the third. So there it is. All right, over here, this one right here is t equals k squared over I, just in case you can't read it. The rest are okay. So the amount of interest owed on a loan, so I equals, so I start off, I equals, it varies directly with the length of time of the loan. So K comes next, and the length of time is T. So literally just put a T right there. So I equals KT, just like letter A. There's nothing talking about a square. Here, the T and the I are in the wrong place. Here, the T is underneath the K. It's not supposed to be like that for direct variation. All right, going on to the next one. So which graph has a direct variation? So basically, this is back to the point I was making on the first page. You have to go through the origin. The direct variation graph always goes through the origin. So that would be this one right here. There's usually some kind of slope to it, some kind of slanted line, positive or negative slope, right through the origin. All right, next one here. Brian built an 83-story house of cards in 1995. He used 27,000 playing cards. All right, so, something I can cross off here. 1995, I mean, who cares, really, when he built it? The important thing is in here that it was 83 stories and it used 27,000 cards. At the same rate, how many cards would it take to build a 100-story house of cards? So basically, then you have 100 stories, and you want to know how many cards it would be. Right? So an easy way to do this is, these are like proportions in a way. An easy way to figure out direct variation questions is, 83 stories takes you 27,000 cards. Right? That should be the same ratio or proportion as, well, the next time I want 100 stories and I don't know how many cards, so 100. And then you can put your x down here. So you can make up a direct variation equation, but this is the same thing. So I cross multiply, I get 83x equals, let's see, add 2 zeros to that. So 27,000 with 2 more zeros. So it gives me 2,700,000. So I'll just divide that by 83. And it comes out to 32,530 about. So it says about how many cards. So 32.5, I would go ahead and say this. All right, so it didn't look like a direct variation question, but it really was. In this question, A varies directly as B. So whenever you read this, you stop and you write it down. A equals KB. I always think, varies directly as, so I take my letter and I write equals K right away, and then whatever letter comes next. It says A is 12 when B is 4. So I'm going to put that in. 12, I don't know K, and this is 4. The problem is just asking me what's the constant of variation. So divide by 4 on both sides, get 3. All right, so finally we've come to inverse variation. Now, inverse variation is when the variables act inversely of each other. So when one of the variables increases, the other decreases. When one variable decreases, the other one increases. So they're like the opposite. They're the reverse of each other. The equation for inverse variation that you have to remember is y equals k over x. So it's not k times x. Remember, direct variation was like this. Inverse variation is k over x. So this is your main equation that you have to kind of memorize and know. Now, just like before, you have another format of it. If you have y equals k over x, you could multiply both sides by x, and you might get another format. So xy equals k. So this is another version of the same formula. And it could be different letters. The k is always there usually. They always usually use k. But just realize that. Right, same as before, you plug things in, find out what k is, and go about your way. All right, so in this screen right here, identify the equations that represent direct or inverse. So in none of these problems are you ever going to have an addition or a subtraction part. So that pretty much takes out this and this. Okay? The rest of these things do look like inverse or direct variation because, I have y equals kx. That's my direct variation. And I have y equals k over x. That's my main inverse variation formula. Now remember, another formula like inverse would be yx equals k. And another version of the direct variation would be y over x equals k. So we have that to go with. So let's look at this first one over here, y equals 1/5 x. That's exactly like y equals kx. 1/5 is your constant of variation. So I would call this thing a direct variation. All right, the next one on the second row, y equals 3 over x. That looks exactly just like a inverse variation with the k is 3. The second one, the next one, y equals 3x. It should be clear that's direct variation. This is your k right here. It looks just like direct variation. Same with the next one, direct variation. That's your k value right here. It could be negative or positive, doesn't matter. And it's multiplied by x. All right, finally, the last row is a little bit different. Here, you have y equals k over x. So if you notice, that looks pretty much like this little format here. Or you could multiply by x and say 1500x, if you like it like that. Both of those are direct variation. So we have a D here. And over here, 1000 equals xy. And if you solve for y, divide both sides by x, you get y equals 1000 over x. So you could have noticed that this one or the 1000 equals xy, those both look like inverse variation here. That one's inverse. Okay, a few more examples. for example 2 here, which of the following represents an inverse variation? All right, so basically, no addition or subtraction, so you know it's not letter A. Letter C looks to me like direct variation. That's y equals kx. So that's no good. All right. Letter D also looks like one of the versions of direct variation. Remember, I know on the last page it was y over x equals 5. That doesn't really matter. It could be x over y or y over x. I like to remember division of the variables is direct variation. Division is direct. So that one's direct variation also. So here we go. Y equals 5 over x could be another version of the same thing. This is the one. All right. Finally, in these problems, you're going to have a lot of word problems, and you just have to filter out the things that you need. So I'm going to be underlining some parts that are important here. In this one, a farmer pumps water from an irrigation well to water his field. The time it takes to water the field, so the time varies inversely with the rate at which the pump operates. So let me write an equation for that. The time varies inversely, so K over R with the rate. Okay. It takes 20 hours to water the field when the pumping rate is 600 gallons per minute. So 20 goes with 600. I'm going to use these first two values to find my K value, to find my constant of variation. So I'm going to take my formula. All right, 20 hours, so that's my time, equals K over 600. So if you multiply both sides by 600, you get K equals 12,000. So what you have right now is you have the value of K for the rest of the problem. So basically what you have is your main equation. You have that time equals K, which is 12,000, divided by R. So basically all I've done is filled in my K value in my equation, and then I can just keep using this until I'm done. All right, so if he adjusts the pump so that it pumps at a rate of 400 gallons a minute. So 400 gallons a minute, that's a rate. I need to plug that into my equation for my R value. So I have T equals 12,000 over R, which is 400. So 12,000 divided by 400, knock out some of these zeros, I get 30. So 30 hours. Now, another good way to do these inverse variation problems, with inverse variation, one variable goes up, the other one goes down. So, in this problem, he went from 600 gallons to 400 gallons. So this is going down. That means that the time has to go up. So, that also means, it has to be more than 20. So that would exclude these two answers. All right, so let's see. Because what was happening is he was pumping it at a faster rate, so it's going to take less time for the water to come out. So that's how we knew. All right. I'm sorry, I said that backwards. 600 gallons a minute. If he only does 400 gallons a minute, he's going slower. So a slower rate would mean there was more time involved. So that's how you know it's above 20 hours. Okay, I'm getting to my last problem here that I'm going to do, because then the next ones you have to do. All right, so example 4. The variable y varies inversely with x. So this statement right here, I write y equals k over x. All right, then it gives me some information. If x equals 8, when y equals 3. All right, x is 8, so I'm going to put an 8 here. I don't know k, I usually don't. When y is 3. All right, I need to solve this for k. So I'm going to multiply by 8 on both sides. So k equals 24. So now I can write my main equation. My main equation is 24 over x. I just figured out what k was. Once I can figure that out, I plug it in here. Then it says find what x is when y equals 6. All right, so here we go with the second part. Find what x is when y equals 6. So I'll put a 6 here, equals 24 over x. If I cross multiply, or multiply by x on both sides, I get 6x is 24. So x must be 4. So that should make sense. If you put a 4 here, 24 divided by 4 is 6. So that makes sense. All right. So hopefully that reviewed what you should know. So spend the next few minutes, pause the video, and do these two problems. Show your work, show your setup. You do not have to write the problems down. So basically, just write number 1 down, show your work. Write a number 2 down, and number 2 doesn't have a lot of work. So pause the video and do those two problems. All right, and these are the last two problems you have to do. These are both direct variation problems. So go ahead and pause the video, do these two problems. These both should have work shown. Okay, so in class next time, you are to turn in these 4 problems for your homework grade, and I'll see you then. Bye-bye.